Okay, the plan for deep learning was 5 chapters, 5 specializations, 5 projects, starting with my favorite, computer vision. So what I did is that I built an Arabic handwritten characters classifier. So we have images of Arabic characters. Let's see. This one, for example, is the most famous and most unique character in any language. Bold. We have all the characters. We have rain. Here we have Kaf. And all the characters. Sheen, Sad, Zain. All of them. All of them. And now I built a classifier for these handwritten characters. I started by loading the data. Now I minus 1 because the label is starting with 1 and the indexing in TensorFlow starts from 0, so I just removed 1 or subtracted 1. Here we have 13,000 training images. Here I pulled and loaded the training data and split it into training and validation sets, then pulled the test data. When visualized, this is how it looks. I know it looks pretty unrealistic actually. We don't uh, usually when we write characters, we write it better than this. This is supposed to be off, and this is off, but this is closer to this, which is that, and that's that. That's yeah. So it's pretty messed up. Then that's the model. This layer started with batch normalization, then a convolutional layer with 64 filters in kernel size of 5 by 5, then MaxPooling, then another C and N layer, batch normalization, 2 convolutional layers this time, each 3 by 3 instead of making one that is 6 by 6. I decided to go with 2 smaller ones to see more features and more unique patterns in the data. Then global max pooling, then some dense layers with dropout, and then the soft max layer with 28 nodes, each for a single character in the alphabet. Yeah, the Arabic alphabet is of 28 letters. Then I compiled sparse categorical cross entropy and used Atom as an optimizer. My metric is accuracy because I won't be able to work well with precision or recall or rock since I have 28 different classes. So the accuracy will be the best option that I have. Then after training the first model on 10 epochs with the training dataset, it got after 10 epochs 20 no not 20 82% accuracy on the training data and 92 on the validation data trained on just 11 minutes, I guess. Yeah, 11 minutes, which is pretty high for a model built from scratch and pretty high for a model with data that looks like this. Distinguishing between these two different characters is actually hard for my eyes, and for a model to see this difference is actually pretty good. And for a model built from scratch to see these differences, that's a really, really high criteria. That's a figure for the accuracies and losses across epochs. Not important, but I see a lot of people do this, so I decided to do it. And then after evaluating on the sum of the test data, 9 images of the test data set, that's the predictions, For all nine, it got the same prediction, which is normal because it had 92% of the validation set, so it's supposed to be good. For this image, this specific fit, for some of the trials that I had, I saw that there was an error in this image, but it worked out in the final version of the model. Then I trained the model on the full training images, the train and validation sets. It got an 89% on the training set, and then I saved the model to evaluate it later in here. Then I decided to build another model, a fine-tuned one, or not fine-tuned, maybe uh, a better version of the model. I decided to go with data augmentation because I only had a fixed number of each class. So I decided to do some data augmentation, random zoom, random contrast, just basic image data augmentation. Then I built the model that I built from scratch. I froze these layers from the start and then the convolution last. So here I left these top layers to be trained. Let's see, I froze the first eight, which 0, 1, 2, 3, 4, 5, 6, 7, 8. I froze. Nah, I froze all of this one because 8 is excluded in Bison. I froze all of these and left these to be retrained with no weights and biases. And after training the data augmentation and the new model, this is called transfer learning. It's not very transfer learning because the first model was trained on the same data set, but I think it's called self transfer or something like that. But that's the basic idea of transfer learning. You take a model that was supposed to be trained on different images, you freeze the lower layers, and train the top ones on your new data. I trained both on the same data because I couldn't find a, a pre-trained model that will accept uh, grayscale images, but it worked out. And then after training the new transfer learn model, it got 85 on the training set and 97 on the validation set, which is a great improvement. And only in 4 minutes of training because I'm only training the top layers. Predictions are good, the same thing. Then I trained it on the full training set, as you can see here. Then I saved the model. Now I wanted to evaluate both models, so I loaded the test labels, test images, then I loaded both models. I made the predictions on both models using both models. I mean, that's from scratch one, that's the transfer learned one, transfer taught one. And then the accuracy scores of both was around, I'm not sure, 84, 94, I guess. Something is off. It's loading. It's not supposed to take this long, actually. Stop, stop, stop. Anyway, it took around, or it achieved around 94 for both, but this one matters the most, the transfer taught one. Then conversion matrix for both models, that's the from scratch one, as you can see here. The best predictions are for the letters themselves. The mistakes in the predictions isn't as much, only in some few areas, but also they are dark, so that's good. The transfer taught one is actually better, but still There will always be errors in each model that you train, and that's it. I'm actually happy with what I did because that's my first computer vision model that I trained myself, and I'm actually proud of it. I I enjoyed it. In the future, I aim to specialize in computer vision, and I hope that this would be a good start for myself, and I hope the future brings more value projects. Goodbye.